let's find the absolute extrema of f of x y equals x squared y on the region where x is greater than or equal to 0, y is greater than or equal to 0, and x squared plus y squared is less than or equal to 4. Okay, if you draw this region, the boundary will be, the boundary curves or lines will be x equals 0, y equals 0, and the circle x squared plus y squared is equal to 4. So x equals 0, there's part of that line segment, right? X equals 0 is the y-axis. Y equals 0. And then basically the quarter circle part in the first quadrant of x squared plus y squared equals 4. This is the xy plane, of course. So we're talking about this region along with its boundary given by these curves. So what do you do first? Well, usually I say, just to have an order to do things, find the interior critical values. Find the interior critical points, let's call them the interior CPs. And you find those by taking the partial derivatives. Now, in this case, I'm not sure it's going to do a whole lot of good, but let's take a look. I don't know if we'll have any interior critical points. So the partial derivative of the function with respect to x is 2xy. The partial of f with respect to y is just going to be x squared. And if you set both of these equal to 0 and solve the resulting system, from the bottom equation you get just x equals 0. And then, well, y can, if you plug 0 into the top equation, it's unclear what y is. So y, y has to be between 0 and 2 if it's going to be in this region or on one of the boundaries. So that's the best you can say. But the thing is, any point that satisfies x equals 0 and y between 0 and 2 does not lie on the interior of this region. It lies here on the y-axis. And that's going to come up naturally from checking the boundary critical points. So we didn't, long story short, we didn't find any interior critical points in this case. Okay, so let's check the boundaries. Okay, the boundary. How about let's go ahead and do x equals 0. Well, hopefully it's clear. If x equals 0 and you plug it in here, it doesn't really matter what y is. You're going to get, for any y value, when x equals 0, you're going to get f a height of 0. So you could say something like this. You could say f of 0y is equal to 0. And that's with the understanding that, of course, y is between 0 and 2. And the same thing is going to happen on this boundary down here, on the x-axis boundary, when y equals 0. So when y equals, so this is one boundary, this y equals 0 is another boundary. But if you plug in 0 for y and anything you want for x, as long as x is between 0 and 2, you're going to get a height value, a function value of 0. So the point x0 would be on the x-axis in here, wouldn't it? Somewhere between 0 and this is 2, right? This is 2. So you plug in any point on that line segment. In here, its y value is 0, and you get a function value of x squared times 0. Whatever x is, you get 0. So the only interesting boundary, or really the only interesting set of points to consider, is on the boundary given by the circle. X squared plus y squared is equal to 4. And the thing is, if you're careful here, you can figure out a nice way to represent the function on the circle by realizing that the function includes x squared. So what do I mean by that? Well, okay, long story short, you can solve this equation for x squared. And then plug this in for x squared in the function right here. So you'll get f of xy is equal to 4 minus y squared times y. As long as x and y is on this boundary. But if you multiply that out, you get 4y squared minus y to the 4th. Oh, sorry, I did make a mistake here. It was, if you go back and look at the original function, it was y right here, not y squared. So it becomes, if you distribute that y, it becomes just 4y minus y cubed. So let me fix that. There we go. Now the thing is, we could call this a function g of y if we wanted to. So we could think of it like a Calc 3 type function. G of y is equal to 4y minus y cubed. And remember, to find the critical values of a one input variable function, you just take the derivative and set it equal to 0. So we could take g prime of y, get 4 minus 3y squared, set that equal to 0, and solve to get the y part of our critical point. So if I do that, let's see, I'll get y squared is equal to 4/3 ultimately, which implies, of course, that y is equal to plus or minus 2 over root 3. Now, do I need to consider the minus 2 over root 3? No, because any point with a y value of minus 2 over root 3 is not, it's not on this quarter circle, is it? It's not along, it won't be a point on this quarter circle. Because this quarter circle lies in the first quadrant, where the points are, or the coordinates are non-negative on all the points. Okay, so cross out the negative part of it. And then we are looking ultimately for critical points on that curve, so we need to get the x value. How do we get the x value? Corresponding to that y value, we realize, oh, x squared is equal to 4 minus y squared. So if we replace y squared with 4/3, we'll get the corresponding x value. So x squared is equal to 4 minus 4/3, which I think is 8/3. And if you take the square root, you would get the plus or minus square root of 8/3 for x, but again, we're not going to look at the minus root because it's not in, the negative root is not on that quarter circle boundary, is it? So the only critical point we're coming up with on the quarter circle then is given by 2 divided by root 3. Whoops, let me get the right order here. Root 8/3, comma, 2 divided by root 3. Okay, so if you want to, you could make, it's almost silly here to make a table of your critical points. But one of your critical points is this guy. So x, y, what is f of x, y then? Well, if you run x equals square root of 8/3 and y equals 2 divided by square root of 3 through the function, you get, if you think about it, the function says to square the x and multiply it times the y. Easy enough to do. So f of square root of 8/3 comma 2 over square root of 3 is going to be 8/3 times 2 over root 3, which is 16 over 3 root 3. And then remember our other critical points were basically this guy and where's the other one? This guy, which both produce 0. So it's pretty clear then that if x is 0 and y is some number between 0 and 2 and vice versa, if we have some value between 0 and 2 for x and 0 for y, we get a function value of 0 there. So this guy would be our absolute max on the region, absolute maximum, and 0 would be the absolute minimum.